So we just did the integration of inverse sine. Let's have a look at the integration of inverse cosine function. Now, you remember earlier in this module when I told you that the standard integral formula for the integration into inverse cosine is actually not given on your table, but we have to remember that all it is that with inverse cosine, we have -1 on top of the square root of a squared minus x squared. Yes, so this is exactly the same as when you get inverse sine, but the only difference is that it's -1 on top. So just remember that the inverse cosine version for the integration is when there's -1 as the numerator. All right, so let's go through questions like we did with the inverse sine. So here we just have a little memory box to remind you of what we're working with. So firstly, we want to find the integration of -1 on the square root of 9 minus x squared. Okay, so similarly with inverse sine, what you want to do is firstly identify that this is going to be inverse cosine. And how you do that is by seeing that -1 up here, yeah? And the second step we want to do is work out what a equals to. Now, 9 can also be written as 3 squared. So once you write it like that, you can easily see that a equals to 3, doesn't it? So a equals to 3, I can just go from here and integrate into inverse cosine. So that just becomes inverse cosine x on 3 plus c. So remember how with inverse sine, I stressed a lot that you always have to include plus c? Well, that applies for inverse cosine, inverse tangent as well, yeah? If it's not a definite integral, with all your other integrations, we have to add your plus constant at the end because we don't know what that constant is. And the question is completely unfinished without it. All right, so you can see very similar process to inverse sine. The only thing is you have to know if you see that -1, your mind should straight away click to inverse cosine instead. All right, great. So that was question 26. All right, let's have a look at question 27 now. So here I want to find the integration of -1 on the square root of 36 minus 9x squared. Now, this is a really, really important question, and this is why. So initially, and with most students, they see this question and they think, oh, that's really easy. A is just going to equal to 6 and x is just going to equal to 3x, right? No, completely wrong. And this is why. With this standard integral formula that we have here, this actually only works if your x squared is exactly 1x squared. Yeah? So this has to be x squared by itself. It can't be 9x squared. You can't have any other coefficient in front of it, which means that you have to get rid of that 9 before you actually apply this formula. Yeah, that's really important for you to know that because about 90% of students make exactly the same mistake. So here we know it has to be 1x squared, all right? So all you need to do is whenever you see a coefficient in front of the x squared, just to factorize that coefficient out. So in this case, it's 9. So all you need to do is just factorize the 9 out. And we know that square root 9 just becomes 3, yeah? And because you can see with that 3, it's out of the side of the square root, which means you can actually just move it to the front. So it becomes 1/3. So now you have -1 on this, and 4 can also be written as 2 squared, yeah? So now I know that a equals to 2, and importantly, this x squared is by itself without any coefficients in front, which means I can actually apply this equation up here. So I can just make that part into inverse cosine of x on a, which is x on 2, and multiply it by the 1/3 out the front, and never ever forget your plus c out here, okay? All right, so I really want you to just memorize that this has to be x squared by itself. It doesn't work otherwise, yeah? Doesn't work unless it's x squared by itself. And this is the same concept that applies to inverse sine and inverse tangent as well, okay? All right, great. So if you know that, then hopefully you won't make the mistake that so many students tend to make, unfortunately. All right, let's go on to question 28 here. So we have the integration of -2 on this, and you can see straight away that we have a 4 in front of our x squared, yeah? And what did I just teach you? Exactly, that x squared has to be by itself, which means I know I have to factorize the 4 out. So I take the 4 out, yeah? Square root 4 is just 2, because we have a 2 up here, that just cancels. So I actually just have -1. And 9 can be written as 3 squared, and that's just to help us find out that a equals to 3. And now you can see this looks very similar to this standard integral formula up here. A equals to 3, substitute it in, so inverse cosine x on 3, and then plus c at the end. All right, so here we're just practicing just factorize out the coefficient in front of the x squared. And if you do enough questions, it becomes second nature, so you won't make that mistake. All right, let's have a look at question 29. So here we're finding a definite integral, and that means we don't need a plus c, but we do need a final answer. So we have the integration from 1 to -1, and you can see we've written it as -dx. So sometimes your questions in your exams, even your books, will be written like this, and some students tend to get confused because you're used to seeing -1, but just remember this is exactly the same as if I wrote -1 on the square root of 16 minus 4x squared times dx, okay? Yeah, so just remember that's the same thing. All right, well, first things first, you can see it's -1 on top, so you know it's going to be working with inverse cosine. Second thing, there's a 4 in front of the x squared, so I have to factorize that out. The square root 4 would just become 2, so that is just half, and I can take that out the front. Now 4 can be written as 2 squared here, and that's to help me work out that a equals to 2, yeah? And then before I apply the formula, I always just double check if that x squared is by itself. Yep, it is, which means I can apply the formula. So I just have inverse cosine of x on 2, yeah? Half can be out the front there, so just put it out the front and you can substitute this in here. It just saves you a little bit of effort. Now we have 1 to -1, so I just substitute that in. So inverse cosine of half, and here we have inverse cosine of -half. And now remember, because with inverse cosine of a negative, remember how that's the one that was different from inverse sine and inverse tan? That becomes pi minus inverse cosine of half, yeah? So you can't just take the negative out. It actually becomes pi minus inverse cosine of half there. All right, so just be really careful with that. Now, we have apply the negative, so that becomes -pi. This becomes positive inverse cosine half. Add them together, that's 2 inverse cosine half. And now we just need to work inverse cosine half out to b, and that just equals to pi on 3, yeah? And just expand and simplify. So here we're going to have 2 pi on 3 minus pi. What does that give you? Yep, it's going to give you pi on 3 multiplied by half gives you -pi on 6, okay? And remember, like I said, because it's a definite answer, we don't have to worry about plus 6. So the difficulties in this question was, first of all, this is just the same as -1 times dx. And over here, remember with inverse cosine of a negative, just a good reminder that it's pi minus inverse cosine in that case.